Yeah, so I think somebody just asked in the chat if the recording of the previous class is available anywhere. Do you want to say something about it, Utkarsh?
Yeah, the recordings will be made available within 1 week of time on the PGSC YouTube channel. So you can fetch them there.
Okay. So do you plan to upload it to the drive and share the link or something like that?
No, I will notify them that the videos have been uploaded on YouTube channel. Once
YouTube.
I
Okay.
get, yeah, it will be uploaded on PGSC YouTube channel. So once
Okay.
I get the information of them being uploaded, I will convey the same to all the attendees.
Okay. Cool. Cool.
Yeah, I have turned on the recording. You can begin.
Okay. So I guess we'll start then. Parth, you're here, right?
Yes, yes, I am
Yeah.
here.
Okay. So let's start and let me share my screen. Just a second. I just hide all my desktop icons. There's too many. Oh, I think Utkarsh, you have to enable screen sharing for other participants. Utkarsh, are you there?
Yes, I'm here.
Yeah, you'll have to give me screen sharing rights.
Oh, sorry.
Yeah, sorry, I forgot to mention it earlier too.
Yeah, now you can share your screen.
Yeah, cool. Mm. Okay, so my screen's visible, right?
Yes, it is visible.
Okay,
Mm.
cool. So hopefully all of you have this package manager called Pip installed. We mentioned it in the instructions. So if, for both Windows and Ubuntu, I think there's a similar way to install. You just download that script that we had mentioned in the document and then run that script. That should have installed pip on your computer. Now, there are a couple of libraries that are not built in with Python, which we will be focusing on. For example, the plotting library, which most people really need Python for, is not available, and that has to be installed separately. So we'll just let these things install in the background and then go back to our homework so that by the time we finish that, the installation will hopefully be done. So even if you're on a slightly slower connection, there should be enough time. Okay, so the syntax to install any library is just pip install and then name of the package. So for example, we need two main packages today. One is called numpy, numpy. So you can just type pip install numpy and hit enter. And yeah, I guess I already have it installed. So it's already done in mine, but you can do it on yours. And to uninstall a package, it's as easy as installing it. You just type pip uninstall numpy, and it'll ask you for a confirmation. You just type Y and enter. Uh, okay, so let me just install it back. Pip install numpy, and okay, if this is taking, so I'm running this from the command prompt. Sorry, I forgot to mention that. On the Windows, it's the command prompt. In Linux, it'll just be the terminal. And if this is taking time, you can let that be in the background, open another terminal, and let's start installing Matplotlib. That's the plotting library. So it's Matplotlib, Matplotlib. And it's the same syntax, pip install matplotlib and hit enter.
Okay, Rohit.
Yeah.
So in Ubuntu, you have to write pip3 instead of pip. Mention that.
Okay. So if in case you have Python 2 and 3 on your system, then pip might refer to Python 2 and pip3 might refer to Python 3. So on Ubuntu, it might just be better if you type pip3 install whatever. But if you have only one version of Python, then it should be okay. And okay, so you can let these two run in the background. So one was NumPy, another is Matplotlib. Parth, maybe you can just type the name of these packages in the chat. And there's one more package that we need that's called Jupiter. So pip install Jupiter. And Jupiter might take slightly longer. Again, because I already have it, it just printed a lot of things saying already present and so on. So Jupiter might take some time. So you can just run pip install Jupiter and let it be for a while. And we'll come back to this later. And okay, so we'll just leave those minimized and go back to the script. So the, okay, maybe a new script. Yeah, so the homework that we had given last class was to write, was to write a script which generates the Fibonacci sequence, the first n numbers of the Fibonacci sequence. Yeah, okay, so there's one more library to install. It's called Python CSV. Parth has just put that in the chat window. You can just copy that command and paste it in your terminal. Okay, so I'm just going to walk you through how I would do it. And if you've already done it, you can just compare notes with how I'm doing it. So first thing was, if you want to generate the first n Fibonacci numbers, then we have a variable for that. Let's say we want the first 10. So let's just say n fib refers to the number of entries we want to generate. Okay, and we need a list which holds the values of the sequence. So let's call it Fibonacci sequence, fib underscore seq. And so you know that when you talk about a Fibonacci sequence, its first two terms are given. Those are the initial conditions. So let's initialize this sequence with two values, 0 and 1. Yeah, okay. And then we start a loop. So for I in range n fib, okay, so 0 comma n fib comma 1. This will start the count from 0, go in steps of 1 up to n fib minus 1. So this will count from 0 all the way till 9. It won't count 10. Okay, and we put that colon at the end, give 2 spaces of indentation. And then let's generate the new entry, new fib. Let's call the current or the next element of the sequence as new fib, and we'll just let that be equal to the terms already present. So fib underscore seq I and I plus 1. So what this will do, you can see, is in the first iteration I is 0, so it'll add the first two terms, and in the second iteration I is equal to 1, so it'll add 1 and 2, 2 and 3, and so on, which is the principle of generating the Fibonacci sequence, adding the previous two entries. And let's append this new value to our list, new fib. So that should be it. And then to print it, let's again start another loop. I in range len of fib seq. So what this does is, yeah. So what this will do is, so like we mentioned last class, len is a built-in function of Python, which gives you the length of a list. So right now we are going to go from 0 to len of the Fibonacci sequence in steps of 1. But so a quick, a shortcut is to leave out the 0 and 1. So by default, Python assumes that if you leave those out and if you only specify a number, it'll start from 0 and it'll go in steps of 1. So that's taken for, those are the default settings. So you can either do it this way and just say print fib seq of I. So to index a list, we use square brackets, not rounded brackets like in MATLAB, and just print. So this should be enough. Okay, let's just save this in the desktop, call it fibseq.py, maybe generate fibseq.py. And so remember to add the .py extension at the end. Do not save it as a .txt. And click save. Let's open the command prompt or the terminal, and then change the directory to where you saved the file. And then let's just run Python generate. Oops. Generate. Okay, so that has printed all the values in the list. So it starts from 0, 1, and then 1 is the next element, then 1 plus 1, 2, 3, 5, 8, and so on. But if you count the number of elements here, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. There are 12. So, but if you only wanted the first 10, then you might have to do a little bit of change to the script. You can figure that out. So either while printing, you can reduce the range. You can also and then uh, just print item. So this is a little similar to MATLAB, I think, where you can just so what this will do is it'll just print, it'll just pick up the elements in this list in a sequence. Uh, sequence. Is it better now? Parth, is my voice okay now? Is it still breaking?
Now it's okay, but say something.
Yeah, okay. Let me continue and point out if it breaks in the middle, and I can just repeat that.
Okay. Yeah.
Yeah, cool. Yeah, so what this enumerate will do is it'll give out two values. One is the index of the list that will get copied to I, and without second for loop also we can print the result when writing print command out to the for loop. Yeah, you can also put the print inside the first for loop if that is what you mean. Anyway, I just wanted to show you the other ways of writing a for loop, which is why I'm writing a second for loop. So here the idea is what you can do is you can print I, comma item. So it will print the index as well as the item. Let's see what that does. Yeah, so it has also printed the index and the corresponding value. And this is probably something we did not mention about print in the last class. You can also separate values that you want to print by comma, and it will just print them one beside the other like this in a single line. But if you want them to appear in a new line, then there have to be two print statements, or you have to add a /n, for example, like that, and go on. Anyway, so what I wanted to introduce is that enumerate function, which can sometimes be useful if you also want the index. Okay, there's some messages in the chat. Yeah, to the first for loop. Yeah, okay.
So Rohit, just
Yeah.
type this command. You can do without for loop also, like print star.
Okay. This the one that you just sent.
Yeah.
Okay, if you wanted to do it without the second for loop, then just comment these two. Yeah, so the star notation, people who are familiar with C might be familiar with that. That I think gives out all the values. But star, I think, has a different meaning in C. Anyway, so this is another way to print the values of a list. And so this just says separate them with this. Okay, let's just see if this works. Okay, that also works. So yeah, this may not be something you use all the time and it may not be immediately obvious to you, but it's just a trick to reduce the lines of code that you write and just make it faster. Okay, so what's next? We have the script ready. Yeah, okay. Now let's talk about importing some libraries. Now let's say this nfib argument, you wanted the user to specify it when they run the program from the terminal. So for that, there is a library called sys that we use to capture any arguments that are passed in the command line. So for example, sys, let's, instead of giving nfib a value of 10 ourselves, let's say sys.argv of 1. So sys.argv captures anything that you run in the terminal, and it's basically a list. And why we write 1 and not 0 is because the 0th element refers to the script itself. So for example, when you write python generate fib seq.py, the 0th argument is this, and whatever you pass after that goes on getting accumulated as in the index positions of 1, 2, 3, and so on. So here we take nfib from the command line itself. Okay, let's let me just keep both of them visible. Okay, so now if we run generate fib seq.py without specifying an argument after it, it'll throw an error saying it could not access this value because we haven't passed any argument. So maybe we can just pass an argument called 10. It'll still throw an error now, but let's see what that error is. Yes, so anything that you type here gets interpreted as a string. So it's thrown an error saying string object cannot be interpreted as an integer. So whatever gets picked up by sys.argv is by default a string. And if you want to change it to an integer, because nfib has to be an integer, we change it to int of sys.argv of 1. So int is another built-in function in Python which lets you convert a number if it's in the form of a string or if it's in the form of a float to an integer type. Okay, let's save that and run again. And yes, so it's worked again. So this makes it easy in case you want to try the same script out with different values or different parameter values, then this makes it easy to specify them in the command line instead of having to go to the script and change a number of values. For example, so if we type 20, it goes on to print the first 20 values and so on. So that's the use of this library called sys. Okay, now hopefully, okay, let's just check the chat quickly to see if there's anything. In second loop, use for I in fib seek print I. Yes, so that's like saying for item in fib underscore seq print item, same thing. So item can be replaced with I or any variable. So I've just said item here, but that is just a variable name. That can be anything. It could be for var in fib print var, and so on. It could even just be I. But generally, the convention is to use I for numeric indexing and not to hold values, that's just the common practice. You might also be familiar with this from C. So you use variables like I, J, K to refer to the indexes and values with some other variable. So it's just a convention. Okay, now let's move on to using some other libraries, like the ones we just installed. Hopefully, all of you have been able to install the NumPy and Matplotlib and Jupyter packages. So I guess Parth, you can take it over from here.
Okay, thank you. So next session will on the Jupyter notebook. So yeah, let me share the screen first.
Excuse me, sir.
Yeah.
Yeah.
Sir, last
Just
pip
tell me.
install Python CSV. When I am installing, so showing so many of error.
Okay. Can you paste one error in the
Error,
chat
it
window?
shows the error.
Yes, sir. So many of red lines in command window.
Okay. Can you read out one of those red lines, maybe?
Error command errored out with exit status 1.
Okay. Something before that.
After that,
Oh, okay. Somebody errored out with exit status.
How to check, sir, it is installed or not?
So are you
it
using
is
Windows
not
or
installed.
Ubuntu?
Window.
Okay.
Windows.
Let me also just try pip install. What was the command? Is there a Python underscore CSV? Okay.
What does Punita? What does mean by pip list?
Oh, pip list I think just lists all packages to see if the ones that you have installed. Okay, I'm just trying to install Python CSV on my Windows, and it seems to be running okay. Let me see if I also hit any errors. Okay, let's see what this error is. The command errored out with exit status 1.
Hello.
Yeah. Okay. Yeah. So even I'm getting this error on Windows.
So okay, so I can skip that part.
Yeah. Okay. So I'll try to figure out what the error is, and maybe you can continue with the rest of the things. And we can. So for those of you who aren't able to install Python CSV, we can just we'll get back to that. We can ignore that for now. But did anybody have trouble installing NumPy,
So guys,
Matplotlib?
we are going to use guys, any issues there? Okay.
So if all of you have managed to install NumPy, Matplotlib, and Jupyter without any issues, that should be enough for now. The Python CSV thing we'll deal with a little later.
Okay. So like continue.
Yeah,
So
I guess you
guys,
can start.
hello. Okay. Yeah. So guys, run Jupyter notebook or start Jupyter notebook. What you have to do, you have to start terminal and just write Jupyter notebook and just press enter. It opens the Jupyter notebook in your default browser. And to open the new window in Jupyter notebook, just press new and open Python 3.69 or Python 3. It's both. What's that?
Parth, are you typing these things in the terminal as you speak? Because we
Just
can't
press
see that.
Python 3.69. I press it.
Can you close and start again? Did you share your whole screen, Parth?
Okay, so what do you mean by typing?
Parth, are you there?
Okay, right. I have some network issue here, so you can continue with Jupyter.
You're not very audible. Can you please speak a little louder?
I have some network issue here. You can continue with Jupyter and
Yeah.
NumPy.
Okay, fine. All right, so let me share my screen and we'll come back to Python CSV in a little bit. Okay, so if Jupyter has installed without any errors, then you should be able to just launch a Jupyter notebook using the command Jupyter space notebook, and it'll open up a window or a tab in your default browser. So Jupyter is basically an interactive Python environment. It's similar to the Python console that we introduced last class, but it's a little more interactive and it runs in your browser. So it's easy to, you can also run scripts within it, and for a lot of courses, they might even accept a notebook as a form of submission for programming assignments. So it's also a nice way to document and make a report in which you also have code which can be run in the file that you submit. So instead of copying and pasting code into a PDF file, you can just submit your assignment as a notebook, and the person reviewing it will be able to run the code and see the plots and etc. So it's a very neat and convenient way. So it opens up a file directory by default, and you can click on new in the top right corner and click on Python 3. So that will start a new notebook, and hopefully this should have worked on all of your computers. And it opens, so this block that's displayed here, it's called a cell. And a cell is basically a Python session that's running in the background. So you can just do the things that we did with the Python console last week, in the last class. And to run the command that you place in a cell, you have to hold shift and then hit enter. If you just hit enter, it will just go to the next line. So to run whatever you've typed in a cell, you have to hold shift and then hit enter. So you can see it's just in basically refers to the command you typed, and out is whatever the output of the code in that particular cell is, and it'll automatically go to the next cell. It'll just create a new cell for you where you can continue typing. So you can do all of the things that we did with the console last week here. So let's start with importing NumPy. To import any library, the command is simply import and then space, the name of the library. And there's also another trick that you can use. It's not really a trick, but it's just a matter of convenience. You can import it as something. So this as just means that whenever you say np in the rest of the program now, it'll refer to NumPy. So for a package that has a small name like NumPy, this is okay. You don't even have to do it. You can type NumPy every time you want to use something from NumPy. But for example, if it's a very long package name like Matplotlib, then it helps to use a short form when you import it so that you don't have to type the whole name every time you want to use it. So let's just import NumPy as np. And whenever a cell is running, it'll display a star in the square brackets just next to in. So you can see Right now, this is happening really quickly. So every time you run a cell, the number just increments. So if you see a star here, it means it's still working, and any new commands that you give will not run until that has finished running. Okay, so what is NumPy? NumPy is basically, let me just show you. NumPy has this elaborate documentation page, separate page for itself that you can take a look at. There are some tutorials even here that you can follow. But basically, NumPy is the library you use when you want to work with matrices and arrays and do operations with these arrays and so on. Because we saw in the last session that with a list, even if you have a list with only numbers, you cannot perform any operations between two lists. So if you add two lists, it doesn't add the values in them, it just appends them. So if you wanted to add the corresponding values element wise, you would have to use a NumPy array. So that's another data type. So we can just say an np dot array of something. So the syntax is np dot array, open and close round brackets, and within that you can mention a list in square brackets. So this will convert the list 1, 2, 3 to a NumPy array. Let's do the same thing for the second one also. And now if we run that, so you see that it has added the numbers element wise. And you can also perform all the other operations, multiplication, subtraction, and so on in the same way. Okay, so now if let's just take a look at one np.array. It just prints out what the array is. So there are, let's assign this to some variable. And then, so again, you can use the len function that we used on a list on this variable. It will show you the length, but there are also things like abs and max that work on lists also work on a NumPy array. And now, so right now, this var1 is just a one-dimensional array. So if you want to check the dimensions of a NumPy array, you can just type var1.shape. That'll just print what the shape is. So this is similar to the size command in MATLAB, if you're familiar with that. So right now you can see that this is just one-dimensional. Let's say we wanted to make a two-dimensional matrix, say 2 rows and 3 columns. Then the syntax would be, so the good thing about Jupyter, basically this is called interactive Python. So the good thing is you can go back to a previous command that you've run, edit it and run it again. In a console, you wouldn't be able to do that. In a terminal, what's run is already done. But here you can also erase the outputs that are printed. So if you run an empty cell, then the output there just vanishes. So it's very convenient that way. So let's say we want a matrix with 2 rows. So how we do that is, let's say we want 1, 2, 3 in one and 2, 3, 4 in the other. I think I missed one. Yeah. So each row must now appear within square brackets. So the first row is 1, 2, 3, second row is 2, 3, 4, and the whole thing is enclosed in a pair of square brackets. So let's, so right now you see it prints, generally it prints multiple rows in different lines, and you can check the shape. It should say 2, 3. Yeah, so 2 rows and 3 columns. Now indexing a NumPy array is also similar to indexing a list. So var1 of 1, shift enter, will give you the whole of the second row. So because the indexing starts from 0, so var1 of 0 will print the first row, and var1 of 1 prints the whole of second row. If you want to index a particular element in this matrix, then you can add another square bracket indexing, shift enter, and this gave you the last element. So that's second row and third column. That's 1, comma 2. You can also index in this fashion without putting them in 2 different square brackets. You can also separate them with commas. And again, if you want to pick up multiple elements, we saw the use of this colon with a list in the last session. You can do the same thing even here. Okay, what else? Let's see. Path had this notebook. I can just follow that. So numpy array, yes, np.lin linspace. So if you remember, we saw how we can create a list of numbers or a sequence of numbers using the range command. There are similar functions even within numpy. So for example, you can use np.arange, which does the same thing as range. So you give starting number, ending number, and the step, and that will just print out the values. So that will give you an array with the sequence of those numbers in that step, starting from 0 and ending at 10 minus 1. Similarly, there's another command called linspace, which MATLAB users might already be familiar with from MATLAB, which does, so for linspace, let's see, 0, 10, and 5. Okay. Yeah. So here again, you give start and stop, but then the last element is not the step, but how many numbers you want from this range from 0 to 10. So it gives out equally spaced numbers which fall within this range. And here you can see even the last element is included, that's 10. And if you change this, that just gives you equally spaced numbers with the start and ending included, and the number of elements equal to the number you specified as the last argument. Okay, that's linspace. Yes, once and sort. Okay. So similar to MATLAB, you have functions to generate a list of an array of just ones or an array of zeros, something like that. And if you want to make it a matrix, then you can specify additional dimensions. Oops, I missed the bracket. Yeah, so you cannot type this without the additional pair of brackets. If you just type np.zeros 5, 5, it will throw an error because the second argument, if you go to the documentation of numpy.zeros, might actually mean something else. So you have to put these within a pair of round brackets. So using round brackets to list some numbers is also a data type in Python. For example, we saw that list has these square brackets at the end, but if you have round brackets, it's called a tuple. So that's also a data type. So you can try typing type of 1, 2, 3, but they are enclosed within round brackets. You see it says it's a tuple. So tuple is also similar to a list in some ways, but in some other cases, it can have some more functionality than a list, but that's not terribly important right now. But just remember that when you have to give these multiple dimensions, you have to pass them within additional brackets. Okay, so those are some useful NumPy functions. Okay, we can skip some of this and yeah, okay. So indexing, oh, sorry. Yeah. Okay, so let's create a slightly longer array, np.array 1, 2, 3, 4, 5, 6, 7, let's say. Okay, now let's say we want to index all the elements that yeah, less than 4. Yeah, so the MATLAB users might be familiar with syntax like this. So you can index Of course, you can index an array using elements 1 to 3. That will just print out the first values from index 1 to 3 minus 1. But if you want to specifically get the values where this variable is less than some number, so for example, var1 of, which is the square brackets, and then wherever var1 is less than 3, only print those values. It will just print that, and where it's equal to 3, it will only print that, and so on. So this can be useful sometimes when you only want to get out certain elements from an array. Okay, anything else? Yeah, another useful function within NumPy is the np.random, which helps you generate random numbers. So for example, if you use randn and write some numbers here, these numbers basically control the dimensions of the generated matrix. So this will generate a matrix of 3 rows and 4 columns with all the numbers drawn from a normal distribution. So you can take a look at np.random in the documentation page. So you can just search for NumPy random, and it'll show you all the functions that you can call from within random. So there's rand, which gives there's randn, which I think gives from a normal distribution. Rand probably gives from a uniform distribution, and so on. So it's just a matter of looking up the documentation and using it. The goal here is to just show you that these things can be done with NumPy. Okay, now NumPy also lets you save values, save a matrix in a matrix format to a text file. So there's a function called np.saveText. Let's say we want to save this variable var1. So we first specify the name of the file that we want to save it to. So let's say var1.txt, and then comma, and then the variable name itself. That will just save it. You can go back to your the page that opened when you started Jupyter and try to look for that file. And yeah, so it's saved them in different lines. And you can see that it's printed many decimal values after many numbers after the decimal value. You can control that using the format specifier that we talked about in the last class. Sorry. You can also specify what delimiter you want between these values. So delimiter is just a character that separates elements that you print to a file. So let's say we give a comma and save it. And let's open the file again. Maybe it's not saved it yet.
Rohit, for that hello. Yeah, for that you need a 2D array. Define 2D array as that.
Okay, let's make this array 2-dimensional. Okay, that's saved. Let's go back and check. Yeah, so it's separated each row by commas. So we had this 2-dimensional array which has 2 rows, each with these numbers from 1 to 7. So if you specify this delimiter, then each element in a row has been printed with a comma separating each of them. So you can also take a look at the documentation for save text to see what else you can do with it. And at the same time, you can also load values from a text file. So let's load the values back that we wrote into, let's say, another variable, var2. Okay, so it gives some errors saying it could not convert the string to float. So if you have used a delimiter, then you have to mention what delimiter it should use. So by default, Python doesn't know that it should take these commas to mean that they're only separating values. because otherwise it will just take this whole row as a string, because there's a comma in between which cannot be interpreted as a number. So, okay, with the delimiter argument specified, that has worked, and we can print var2, and that has just loaded it back. So save text and load text are just convenient functions to use when you want to save matrices to text files directly or load them quickly. Okay, I guess we'll quickly move to the next package that we want to show. That's Matplotlib, and maybe come back to NumPy if there's anything else later, because it's already 10:50. Okay, so now let's import matplotlib.pyplot. So Matplotlib itself has many other sub modules within it, and for plotting, the most important one is pyplot. So you can imagine now if we had to type matplotlib.pyplot every time we wanted to use some function from it, that would be very tedious, which is why it helps to just use an alias, which is PLT. That's just the regular convention you'll see on the web, or if you find codes from somebody else, you'll see that PLT is usually the convention to use for pyplot. Okay, so let's import pyplot as PLT. And the most basic function in plotting is this plt.plot, which at the very least takes one array of values. That's all it needs to plot. So by default, it'll assume that these are the y values, and the x values are just the indexes. So 0, 1, 2, 3, 4. Those are the x values, and the corresponding y values are what you have specified. So you can just run plt.plot, and it will show you the values 1 to 5 plotted against 0, 1, 2, 3, and 4. It shows a connected line because even though these are just distinct points, it has connected all of them. So there are some neat things you can do here. You can change the color of the plot by just typing color equal to, let's say, green, and that changes the color of the plot. And you can say specify marker equal to X. So that will keep the lines because you've used plot, but at each point, it will also show the marker. It'll show a marker which is specified with X. That there are some parameters that, so there are some possible values for this marker. For example, if you put O, it puts these filled circles. So I'm not going to give you an exhaustive list of what all you can put for this marker argument. You can find that easily on Matplotlib's documentation. Again, it's as simple as just going to Matplotlib pyplot. It has a separate page, and they have some examples here that you can look at, and so on. So there's a lot here. There's a lot of documentation available for you to try things out. But we'll just introduce you to some of the main ideas here. And so for people who are working in DSP, things like that, a stem plot is something that might be of interest to you, where every point is also marked by a straight line extending from the base to that point. So you can just say plt.stem. And yeah, so for this, some parameters might not work. Let's just do the stem plot. And yeah, so the stem plot just also adds these vertical lines leading up to the value. If you want to plot these y values 1, 2, 3, 4, 5 against some specific x values, then you can also pass that as another argument. So let's say we plot it against 4, 5, 6, 7, 8. So the x-axis will now change to those values. So by default, the convention is the first list you provide is the x-axis, and the second list you provide is the y-axis. Okay, and there are, now let's say we have this plot ready. We want to add a title, X label, and Y label to this. So what we'll do is we'll just go to the same cell, hit enter, that will take us to the next line. And let's say there's a function called xlabel, plt.xlabel, where you can just specify let's say our x-axis is time, so we'll just say time, and plt.y label, that's just let's say amplitude, and let's run that. So it's shown time and amplitude in the x and y axis. If you also want a title, then it's just plt.title, and let's just say graph, or let's just say stem plot. So you'll see that it says stem plot in the title and time and amplitude in the x-axis and y-axis. There are also some other things you can do. For example, let's say, yeah, maybe we'll leave this at this right now and go to having subplots. That's also something common you might want to do commonly in your, maybe when you want to write a report or so on. So there is a function called plt.subplots. And although you can just call it like this, it's more convenient to call it using, calling it in this way. So plt.subplots actually returns two arguments, fig and we're just going to pass them into these variables called fig and ax. So fig is just an object which holds the whole plot together with all the subplots, and ax helps you plot in those individual subplots. So now to plt.subplots, a mandatory argument is how many rows you want and how many columns you want in the subplot. So let's say we just want two plots, one below the other. We'll just say 2, 1. So that's 2 rows and 1 column. So that'll, if you just hit Shift Enter here, it'll just show you how these two subplots are created. And then if you want to plot something in the first one, then we can index it using ax of 0. So ax is basically a numpy array which holds each of these plots separately. So ax of 0 refers to the top figure. So let's say, now similarly, like we said plt.plot earlier, we now have to say ax of 0.plot, and let's say we plot some numbers, and ax1 of ax1 dot plot and some other numbers 3, 4, 5, 6. Hit enter. So you can see that it has plotted both of them. If we wanted maybe 2 more plots to the in a second column, then we would have said 2, 2, and that gives us 4 subplots. In that case, you can't now ax will be a 2-dimensional array because it's 2, 2. So you have to index it using 0, 0, 0, 1, 1, 0, 1, 1. So 0, 1. We can just try this. Yeah. So the order of indexing is this is 0, 0. This is 0, 1. There's a message in the chat. Can we multiply to different size array? Okay, I can, let me just finish this and answer that. Yeah, and then if you want to plot something here, that's 1, 0, 1, 1. And yeah, so this is just an easier way of doing subplots in MATLAB. And again, yeah.
Sir, when I am using plt.stem that showing error module, Matplotlib has no attribute stem.
Sorry. So did you import Matplotlib in this fashion? Import matplotlib.pyplot as plt?
Yes, yes.
And you did plt.stem in the same way?
Yes, sir.
And did you pass 2 lists as arguments, x and y?
No, only 1 argument.
Okay, let's. Okay, that also works.
Did
So
you
what?
install the Matplotlib?
Yes, sir. I had installed.
Yeah, if it's importing, then.
Yeah, which OS you are using?
Window.
Windows, okay. So just try to import a Matplotlib.
Sir. Import. What's it, sir? Matplotlib.
Matplotlib. Yeah, that's it.
Yes, sir.
Does it work?
Just a second.
So it shouldn't show any errors in importing. It should just run without any output if you just type import matplotlib.
So yeah.
Yes, sir. It's still showing error. Module object is not callable.
Yeah. So you didn't install Matplotlib properly. Yeah. We will talk later, like after this session.
Okay.
Yeah. Okay. So that's about subplotting. Yeah. Just one more thing. So if you want to control the X and Y labels of each one of these plots separately, then instead of using PLT like we did earlier, plt.xlabel, you use the individual handles that are available. So AX 0,0. When you do it in this fashion, there is slightly different syntax. So you have to write set underscore X label. That's just the way it is, unfortunately. And yeah, maybe we should increase the figure, or maybe let's just make it Y label. Yeah. So what happened was when I set the X label, it went below the axis, and because the subplot below is covering it, it wasn't visible. So another, yeah, maybe let's keep X label and let's say plt dot type. Yeah. So this command tight underscore layout can be a very useful can be very useful. So what it does is automatically positions all of these and separates them enough vertically and horizontally so that all the axis labels will be visible if you choose to put any of them. So right now, even if we have put the X label, it's visible because the plot below is not covering it. So the command is just plt.tight underscore layout, open and close curly brackets. So that's about the basics of Matplotlib. If there are some other specific things you want to do, we may not be able to cover all of that, but this is just to give you something that you can start with. And you can, the easiest way to find solutions to any problems that you get stuck on is to just search it up, look it up on Google and just go to Stack Overflow. You'll usually find an answer that works for you. So Python has become a really popular language for the community. So there is a lot of support available, and most problems that you might face, somebody else would already have, and that would have already been answered on Stack Overflow. So that's a really good place to look for solutions in case you get stuck somewhere. Okay. So just one more thing. Right now, within Jupyter, if you just type every time we plotted, say for example plt.plot, it directly displayed the plot when we hit enter. But if you're running it from a script, you'll have to use another command called plt.show to actually show the plot. I'll cover that when we get back to the script now in a minute. But just to remember, that's something. You can also plot 2D matrices like an image. You can look up plt.imread, plt.imshow. So these are functions which help you load an image file from your computer, and that's using imread, and imshow helps you plot it and visualize it. So you can look these up. Those might also be useful if you ever want to work with images and 2D data. So for example, for people who are working on audio signals, a spectrogram is a 2D representation. It's like an image, so you might want to use imshow in that case. All right, so that's about Jupyter and some of these packages. And once you're done running things in a notebook, you can save it either using save as, or you can just say save and checkpoint. So if you do not do the checkpoint and you just close it without that, then all the changes that you might have made now, the latest changes might not get saved. So you can see that it says last checkpoint a few seconds ago. So all that we've done now is saved. And you can change the name of the notebook by editing that. Just click on that word that says untitled and test notebook and just click rename, and that will rename it. And if you want to close this notebook, you can just go to file and close and halt. So that will close this notebook and close the tab also. And you can just go back to the Jupyter, the tab that Jupyter first opened. And another thing to remember is, so let's go back to where we started Jupyter. Okay, let's just quit this session of Jupyter. You will see in the console that even that will have ended. So one important thing to remember is, so right now the path we are at is the desktop. So if I run Jupyter from here, then I can only see the files within the desktop in the file browser here. So if I wanted something, say in my E drive or something in a different drive in Linux on a different partition, then you have to go change the directory to that location on your terminal and run Jupyter from there. So for example, right now I can't access anything that's on my E drive. So I'll have to first change directory to E and then run Jupyter Notebook from there. And that will show me all the files in the E drive when it opens up. Yeah, so this is what I have in the E drive. And yeah, and now I can't access the C drive and vice versa. So just remember to change the directory to the path where you know your files are just before you run Jupyter Notebook. Okay, there's some message. Oh, I think there was one question on multiplying. Oh yes, sorry. Okay, let me quickly. So the short answer is you cannot multiply two arrays of different sizes or even add. It will throw an error. For example, let's just say import numpy is np and var1 is and var2 is, let's say 1 2 3 4 5, and var1 times var2 should not be able to do element-wise multiplication. That will fail. So it'll say operands could not be broadcast together with these two shapes. So they have to be of the same length. So for that matter, you can't even add them. You can't do any of these. So by default, this means element-wise operation. When you add two numpy arrays or when you perform any operation between numpy arrays, it's element-wise, which means the arrays have to be of the same dimensions. But you can always do a dot product. But even then, no, I think you need to have same, yeah, even for a dot product, you need to have same lengths, but you could have 2D arrays of different sizes, but compatible so that you can do dot product on them. So I hope that answers your question. Okay, cool. So let's exit this. There's just one last thing we want to cover in today's session. That's about writing functions. Okay, we can quit this. Okay, so let's go back to drive. All right, let's say, okay, we had this Fibonacci sequence script from earlier. It's often convenient to write things in functions, and so that you can just make a call to that function and not only if it's necessary and not executed every time your script runs. So one way is you can just comment out these lines, but otherwise you can put them inside a function and that code will run only if you call that function. So the syntax to define a function is it has to start with this keyword def, and then you have to give a name for the function. So let's say gen fib seq for generate Fibonacci sequence, and and you have to put these open and close brackets, and again put the colon. That's like we saw in the case of if and for. So whenever there's going to be an indented block, there has to be a colon before it. So even in the case of a function, whatever you want to be within the function has to be indented. So let's put this whole for loop block within the function definition. So everything has to be indented to lie within the DEF. So now what I have done is from the level that DEF starts at, I've added 2 spaces. So for starts 2 spaces after DEF. So that comes within the function. And whatever you want to be within the for loop itself, again, has to be indented. So that's again indented by 2 spaces. It can be 2 spaces or 4 spaces, whatever, but remember to keep it consistent everywhere. That's all. It can also be a single tab space. Sorry. Now, when you define this function, within the round brackets, you have to specify what parameters the function will take, what arguments it will take. Sorry. So in our case, the only parameter we want to pass is how many numbers in the sequence we want to generate. So let's call it nfib, that's the argument, and that gets used in this for loop. So whatever is not defined within the function has to be passed as an argument. So you can see the function also needs FIB-SEQ. And so if you just run this right now, it'll throw an error because within the function, this has not been defined. It was defined a little earlier. The general practice is to also pass whatever you need. But Python generally has this concept of having all these variables global in a global scope, so that this function actually can see this variable, but it's good practice to pass all the variables that you want the function to have access to, so that you know what variables are being modified by the function itself. So let's also pass the array FIB-SEQ. So let's see now if it is all okay. So for I in range 0 and fib, we have passed that as an argument. And new fib, FIB-SEQ, that is also fine. And it will just append a new value there. Okay. So now that's the end of the for loop. But now we also want the function to return this updated Fibonacci sequence array. So we have to add a return statement that also has to be indented 2 spaces or whatever you followed for the for, but it should not be 2 more spaces. That will mean that the return is within the for loop. So it should be at the same level as the for loop, and then return space whatever variable you want to return. So if you want to return multiple values, they can just be separated by a comma and so on, something like that. You can also put them in a list and return the list together. So I think in C, there usually used to be this problem that you can only return 1 variable at a time, but in Python, you can just separate multiple variables with commas and just return them. But you should also remember that the output, when you call this function, that is returning 2 values. So you should have 2 variables to capture those variables. But if you put it within a list, then even a single variable is okay, because the list itself is a single data type, it's a single variable. But if you just separate 2 values with commas, then it is going to return 2 variables, and you need to have 2 variables to capture it. Okay, so now this function is ready. Let's call the function. Calling the function is simply writing the name and make sure it's not indented. Yeah, so gen FIB-SEQ and passing the parameters and fib, comma, FIB SEQ. That's it. So now, but we also want to store what it returns. So let's say FIB SEQ updated, let's call it. And maybe we can call this FIB SEQ initial. So let's call it init. We'll also modify it here. So we are passing FIB SEQ init. So one thing you notice here is that we have written FIB SEQ init here, but we don't need to modify the parameter that you've written when you define the function. So this can be, and these two need not be the same. So Python will just interpret that whatever you pass in this second position will go into this FIB-SEQ variable. And it will just use that value for the rest of the function itself. Okay, so we'll get the updated sequence from the function, and let's print the updated function. Okay, let's save this and run it. Python generate fib-seq.py. Oh, we have to pass a command line argument, which is how many numbers we want. So let's pass 10. And okay, so it's worked the same way that it was that it did earlier. Okay, so if you're going to have several functions for various purposes, then it's usually good practice to define them at the top of your script. So the general practice or the general convention is to first, at the very top of your script, have the import statements for all the libraries that you want to import, and then all the function definitions, and then whatever other commands that you want to run. That's the general convention of writing a Python script. But you can also import it later. It's okay. It will not throw an error. So long as you have not used this package before it was imported, it's okay. You can also import it just before you need it. That's also okay. But it just helps make the script a little more easy to understand if you follow these conventions. Okay, Parth, is there anything else for today's session? Or if anybody else has any questions, you can ask us now. I think this is about it.
Okay, Rohit. So it's okay, I think so.
Yeah, I think we've covered most of what we wanted to. If anybody has questions, please, you can ask us now.
Okay, so who has a problem with Matplotlib?
Sir, I have problem, sir.
Okay, so did you try to install Matplotlib once again, like Pip 3 or Pip?
Sir, I had installed once again.
Did it throw any error when you ran the pip install command? Was there any
No.
error?
No.
Any red lines over there or something like that?
No, sir, no red line.
Were there any warnings, anything at all?
No warning.
So okay, try to write Python in your command window.
When I'm checking Matplotlib import in a command window, that then shows no error.
It don't show any error. So yeah.
So had you launched your Jupyter notebook before you installed Matplotlib?
When you told launch, then I had launched, otherwise never launched that.
Okay, and had you finished installing Matplotlib before you opened Jupyter notebook?
Yes, sir.
Oh, then Jupyter must have had access to it.
So yeah, try to write Python. Which version is it?
3.8.
So supposed to be what?
Yeah, that's fine. Have you used Python 2 on your system before?
No, sir. I had never used
Okay.
Python.
Yeah, then it should be okay. Okay.
Just try to uninstall and remove Jupyter and again install it.
What, sir?
Uninstall Jupyter and install it again.
Uninstall.
So pip uninstall Jupyter.
Jupyter.
Yeah. But you're sure that when you write Python in your console and type import matplotlib.pyplot, it does not throw any error?
सर आपने क्या कहा?
When you write Python in your command prompt,
Yes, sir. No error. That time shows no error.
Okay.
When importing that, then also shows no error in command
Okay.
window.
Okay. Fine. Yeah. So maybe you can try uninstalling it.
Okay. Any other queries?
Excuse me, sir.
Yeah.
Yeah, I'm having problem with that sys.argument. It is showing list is out of range. List index is out of range.
So did you pass an argument when you ran the script?
Yeah, it is not showing the option to pass the argument.
Okay. So is this the code that you've written? Import sys and then nfib equal to int of sys.argv of 1. Is this also what you've written?
Yes, same.
Okay. So then when you run the script in your terminal, you have to write Python, name of the script, and then you have to give an argument. You have to give a number.
Actually, I'm using Anaconda package. In that, I'm running the script in Spider.
Oh, you're running the script. Oh, okay. So how is there an option to just at the top, like in MATLAB, to just hit run and it'll run? Is that how it is?
Yes.
Oh, okay. So that won't work. You'll have to call the script from some terminal. You can probably Anaconda must have some terminal also, right? The window.
Yeah, Spider is like that only. To write script and run using
Correct, but
IDE.
correct. So there should also be a small sub window with the console, right?
Yeah, it is there.
So
That's
there you have
where
to
I'm
run.
running the program. Yeah, that's where I'm running.
And you're running the same with an argument after the file name.
Yes, it is showing the error of list index is out of range.
It should show that only if you don't pass this argument after the file name. So for example, I've written Python generate fib seq.py space 10.
No, I'm first running the program, running the file, and after that it is showing the error.
So if you simply run it from Spider. So if you by running, do you mean just clicking on the run option F5 or F10 or something like that?
Yes.
So that will not work because that run does not take an argument. So if you want to run it without an argument, you have to run it from the console. So you have to call the script
But
from
in
the console.
in the Spider console, that Python space file name .py don't run actually.
Oh, why not? What does it say?
I don't know.
Is it an IPython console? Does it say IPython console?
For IPython also I tried, but it doesn't work.
If it's an
It's
IPython
saying
console, you have to
invalid
write.
syntax.
Yeah. So if you're written in IPython console, you have to write run file name and 10 instead of Python. So you can't say Python inside an IPython console. You have to say run
Okay,
space
it ran. Thank you.
file name and then space. Okay, cool.
It ran. Thank you.
Yeah. Okay. Why does the chat not open? Yeah, run same thing. Yeah. Okay. So did you uninstall and install Jupyter? Who was that having trouble with?
Yes, sir. I had uninstalled Jupyter.
Okay. Did you install it again?
No, I not install, only uninstall.
Okay.
It's
So go ahead and install. Did it finish uninstalling?
Yes, sir. Jupyter installed.
Okay. No errors, no warnings, nothing, right?
Yes, sir. No warning, no errors.
Okay. Now run Jupyter space notebook. the notebook open in a browser?
It's showing, sir, Jupyter, exception Jupyter command Jupyter notebook not found.
Okay. So the first time you installed Jupyter, it must have shown you some warnings about some paths not being included. So are you in the same console where you first tried to install Jupyter?
Again install.
No, no. So are you in the same command prompt window where you first installed Jupyter? So the first time that you ran Jupyter install, was it in a
No,
different
no.
window?
So,
Have you closed that?
uh, what, sir?
So when we asked you to install a Jupyter notebook, you must have run pip install Jupyter, right? The first time that you ran
Uh, that
at the
window
beginning
not
of the
same,
session.
sir. Beginning of
Okay, so
session,
you have
I
closed
had
that.
installed another window, and I'm now installing another CMD window.
Okay. So when you installed it, then it would have shown you some warnings saying some path is not part of. So it would have shown you some warning like that. Let me see.
That time not shown error, only shown error for uh, Python CSC.
That was an error. That's okay. But maybe you can try doing this. Let's see. So are you on Windows 8 or 10?
Window 8,
Okay,
8.1 actually, sir.
fine. That's okay. Mm, yeah, maybe you can try this. So go to Start and open. Just type environment variables.
क्या सर कहाँ पे?
Start. Go to your Start menu
Yes sir.
and type environment variables.
ये तो सर प्रॉपर्टीज में भी आता है ना ये?
हाँ. Okay, so somebody has a suggestion. Python -m notebook is a workaround to start Jupyter. Okay, so maybe you can try that. Okay, so just go back to your console, and instead of running Jupyter notebook, can you run what Puneet just shared on the chat? Python space -m space notebook. Can you see that in the chat?
It says warning Python notebook workaround to start Jupyter.
So just run whatever is within those double inverted commas, Python -m notebook in a command window. See if it opens Jupyter.
Yes sir, it is open.
It is? Okay, great. Thank you, Puneet. I wasn't aware of that. There's also another workaround to add a path to your environment variable, but okay, that's slightly more complicated. But yeah, thank you for that suggestion. Yeah, so is there anything else? Anybody else has any other questions? Otherwise, I think we are done for today.